Okay, next question here. Confidence intervals. So confidence intervals is the range where we feel that the population mean probably is. So a large confidence interval means the average could be anywhere within that range. The small confidence interval means similar thing. Let me give you a specific example. Let's say we're trying to calculate the percent of Americans who are Republican. And let's say we get our best estimate based on a sample of 52%. Now, because we're taking a sample and not the population, we're not sure that the exact average of the country is 52%. So we have a confidence interval. Now, if it's say between 50 and 54%, that would be a small interval. If it's between 40 and 60, that would be a large interval. Which would we prefer? Well, we want small intervals because that gives us a pretty accurate idea of exactly where the true population mean is. So smaller because it's a more precise estimate. Okay. This was a kind of difficult question, I think. So the basic two that people chose here were disproportional, stratified, and purposeful. First of all, purposeful will go more with qualitative research, and it's more based on case studies where you're just having a pretty small sample. When you're doing a larger sample or a statewide sample like this is, that is when you're going to use quantitative methods such as disproportional. Beyond that, the reason that this is a good answer, the best answer, is because by a disproportional stratified sample, the whole idea behind it is we want to make sure that we get the precise proportion of, say, art teachers, foreign language teachers, and health teachers. So if we want to make sure, if we want to make sure that we get the same amount of art teachers, foreign language, and health, even though they're not nearly as common as these three, math, science, social studies, we set up a disproportional stratified sampling. So a regular stratified sampling would be we want the exact percent of the population. There's 5% of teachers are math teachers. So if we take a sample, we want 5% of our sample to be math teachers. That's just normal stratified sampling. Disproportional means even though there may only be 1% of the teachers as art teachers, we want it as 1/6 of our sample, and foreign language is 1/6, health is 1/6, math is 1/6. Each of these on an equal level, even though it's not really representing the proportion that's in the population. It does allow us to make comparisons better. It gives us more power to make comparisons. Okay, another deleted item. Okay, mean of a normally distributed set, and we have a standard deviation. So this is the 68, 95, 99 rule that I mentioned in one of the videos. 68% of the data in a normally distributed data set is within one standard deviation above or below the mean. So in this case, if the mean is 70, standard deviation is 5, we know that 68% of the data is between 65 and 75, quiz scores of 65 and 75, because that's one standard deviation below, one standard deviation above. However, that's not what we have. We have between 60 and 80. So we actually went 2 of these standard deviations below 70 and 2 of these 5s above 70. So to go from 60 to 80, we went 2 standard deviations. So 68, 95, 99 rule, 95% of the data in a normally distributed data set will be between 2 standard deviations below and 2 standard deviations above. So that's the 95. Okay, true experimental design. Um, so Macmillan brought this point home, and I think I reinforced it, that a true experiment is the best way to conduct a statistical study when we want to see if there's an effect and what the effect is, because it allows us to control for all the variables except the treatment, and that way if there's a difference in the outcome, we know it's because of the treatment and none of these other confounding or extraneous variables that we mentioned in an earlier video. So an experiment is wonderful for internal validity. External validity, it's usually not very good at all. In fact, this is one of the areas where education research will often be better than scientific or than medical research, for example, because medical research will almost always go based on some kind of convenience sample. And while education research admittedly does use a lot of these convenience samples also, there can be more random selection because we're not putting the subjects through as dangerous or risky of things. Educational research tends to be very light in terms of the risks that a participant takes, whereas medical, it can be pretty serious. So external validity, experimental design does nothing for external validity, only for internal validity, and it gets that internal validity because of its random assignment. So these are two very strong characteristics of the experiment, and the fact that we control all of these variables except the treatment. Okay, this is something that you would want to know when you do Google searches, or especially ERIC searches is what it's set up to be. 300 citations on self-concept, 250 on self-esteem. So when we use this or, what that means is we'll pick up anything that has self-concept, or if it has self-esteem. Now if it has both, we'll also pick that up. So we'll pick if it has one, if it has the other, or if it has both. Now the fact that it has both means there could be some overlap. In other words, if there was no overlap, we'd get 300 for this one, 250 for this, so we'd get 550 total. But because there's overlap, we could get most, if not all, of these 250 ones for self-esteem included in these 300 for self-concept. In other words, we're not going to get lower than 300 because we know we have 300 just for self-concept alone, so we'll at least get 300. But there's no way we can get above 550 because we can't get more than the number of self-concepts plus the number of self-esteem. Okay, next question. So we're looking at average reading achievement scores for gender and grade level. And I would strongly recommend plotting these out. So maybe on the x-axis, do grade 4, grade 6, grade 8, and then do males in one color. Maybe plot 20, 25, 45, and females 30, 35, 55. What you'll notice is the slope for the male lines is parallel to the female slopes. In other words, the slopes are no different between male and female. So what that tells us is there is not an interaction. An interaction would be if the slopes are different. So certainly if the lines cross each other, but even if they don't cross, if they're different slopes, then it tells us that there is a different effect depending on which category you're in, if you're, for example, male or female in this case. Main effects, on the other hand, is right here, which is where females scored higher than males in both cases. Okay, so no interaction because the slopes were the same. Okay, standard deviation. Mean and standard deviation are both things that we cannot use with categorical data. Categorical data, remember, is something like what color is your car? Red, blue, green. What's the standard deviation of that color? That doesn't even make sense. The standard deviation, even if you're not real savvy on the formula, you know that it has lots of numbers and calculations involved. So how would we plug things like red, yellow, Democrat, Republican, how would we plug that into the calculation? We can't, because it's meaningful only when we have this continuous data. Okay, so the key point in this question is they concluded that the programs were equally effective. In other words, they didn't reject the null hypothesis. Okay, their null hypothesis was that the two programs were equally effective. They didn't reject it. Failure to reject a null can only be a type 2 error. Now, it could be a correct failure to reject the null, but if their decision was incorrect, if they did make some kind of error, it had to be a type 2 error. If you reject the null, the only kind of error was a type 1 error. If you fail to reject, it can only be a type 2 error. So there is enough information, and if an error was made, it was a type 2 error in this case. Okay, internal and external validity, and one or two students wrote me that they felt there wasn't enough information in this. This may be a case where there's a okay answer and then a very good or best answer. If we're looking at implementing silent reading, but we're in a noisy classroom, and then we move to this quiet laboratory, we're going to be able to tell the silent reading whether or not that's effective. We're going to be able to tell that better. In other words, we're going to have a positive impact on internal validity. And I think most of you got that based on the answers I'm seeing there. What was more difficult for most people is that result is a negative impact on external. So yeah, we find out that, okay, it is effective to implement silent reading, but so what? In reality, almost any classroom is going to have these noises and these distractions. So if this quiet reading doesn't really work in the real classroom, then we can't generalize it to the population. So by moving it to the lab, it became more experimental, but it definitely decreased our external validity, so positive and negative. Okay, all else being equal, increasing the sample size increases the probability of rejecting the null. In other words, this is called buying statistical significance. By more money, you can get a bigger sample. Bigger sample means you're more likely to find a statistically significant result. At this point, I do want to reward the people who are actually listening to the video. So if you email me the word camel, that will tell me that you were listening to this, and I'll give you some extra points there. Okay, and the final question we'll get to in this video. When we do statistical inference or null hypothesis testing, we're trying to really figure out about the population. That's what we care about. So we don't really care about the sample. It's just we don't have the means to study the entire population. That's why we draw a small group of people. So that's what we're looking at. We're looking at the characteristics of the participants in the sample. But what we really care about when it's all said and done is the population. That's what research is, inferential research, looking at a small scale and then extending it, generalizing it out to a bigger scale that would affect people even who aren't in the sample.